Hey everyone, I hope you're doing okay. We are going to move on to Cluster 6, Day 3, which is basically reviewing the first set of exponent rules we have learned. Okay, so don't forget that the bottom number is basically known as the base. The little top number, it's known as the exponent. That exponent tells you how many times you're going to be multiplying the base with itself. So, for example, they're telling us 3 to the power 4 means 3 times 3 times 3 times 3. So you're doing the multiple of 3 or multiplying 3 4 times, okay? Which will give you 81. So let's go ahead and do number 1 and number 2, and let's review those exponent rules, okay? So let's start with number 1. I noticed that I'm multiplying, so I'm just going to multiply the same bases. And remember, the rule says if you multiply the same base, then you add the exponents. So I'm going to start with everything that has a base of 2. So we have 2 to the power 4, 2 to the power 4. Okay, so that means I'm going to multiply the same base by adding the exponents. So that's going to be 4 plus 4. Okay, and then I'm going to do everything that has a 3, a base of 3. 3 to the power of 0 and 3 to the power of 1. Remember, if a number doesn't have an exponent, it's implied to be 1. Okay, so that means I'm going to multiply the bases by adding the exponent. So that's 0 plus 1. And make sure you add your multiplication symbol in between both of those. Now we're going to take care of the bases of 4. So 4 squared times 4 to the power of 1. Remember, since a number doesn't have an exponent, it's implied to be an exponent of 1. So we're going to multiply the bases by adding the exponent. So that will be 2 plus 1. Okay, and so now 2 to the power of 8, because 4 plus 4 is 8, times 3 to the power of 1, because 0 plus 1 is 1, and then 4 to the power of 3, because 2 plus 1 is 3. And there's my final answer right there. Now you might say, Mr. Gomez, why can't we just multiply all those together to add the exponents? Well, we cannot, because they all have different bases. This one has a base of 2, this one has a base of 3, and that one has a base of 4. So the only way we were able to combine them with the product rule was by multiplying the same bases, okay? Let's move on to number 2. Number 2 is the quotient rule. So remember, anytime you're dividing the same base, you can subtract the exponents. So a very common mistake some of you were making in the previous lesson was that you were trying to do 3 minus 5, or the bottom number minus the top number. That is incorrect. You always start from the top exponent, and do 5 minus the bottom exponent, which is 3. And so 4 to the power of 2, because 5 minus 3 is 2. And there's your final answer right there. Okay? You have simplified the problem. Okay, let's move on. Number 1, applying both laws. So there will be problems where you can actually do the multiplication rule first and then the quotient rule, okay? So let's start with number 1. First thing I want to do is I want to see if I can multiply anything together. And if you notice at the top, I can multiply those two threes together. So multiplying the same base by adding the exponents. Okay, and then the bottom number, I'm just going to leave it like it is, but I am going to add an exponent of 1. Since that 3 doesn't have an exponent, I'm just going to add a 1 to it. And now if I simplify that, okay, I get 3 to the power of 21 over 3 to the power of 1. Now I can do the quotient rule because I'm dividing the same base. So 3 to the power of 21 minus 1. Okay, because remember, when you divide the same bases, you subtract the exponents. So 3 to the power of 20, because 21 minus 1 is 20. And there's your final answer. Okay. Okay, let's move on to number 2. If you notice, at the top, I can combine those two bases together by doing 11 to the power of negative 2 plus negative 2. When you're multiplying the same base, you add the exponent. As for the bottom number, I'm just going to leave it like it is. I'm not ready to mess with it. So let's go ahead and fix that. So 11 to the power of negative 4, because negative 2 plus negative 2 is negative 4. And you can use your calculator to add those two numbers if you need to. Okay? And then the bottom number is 11 to the negative 4. Now I can use my quotient rule to divide. So when you're dividing the same base, you subtract the exponent. So here we go. My base is 11. Now I'm going to do the top exponent, so write that down, minus the bottom exponent, which is also negative 4. Okay, that's another mistake some of you were making. You were trying to say negative 4 minus 4. That is incorrect, okay? We are trying to do negative 4 minus negative 4, okay? Because we're doing the top number minus the bottom number, okay? Or the top exponent minus the bottom exponent. So now you get negative 4 minus a negative 4. When you do that, you end up with 11 to the power of 0. Technically, that is the correct answer, but in reality, we know that anything to the power of 0 is 1 based on the 0 exponent rule, okay? So really, the answer I would prefer for you to put down would be 1, because 11 to the power of 0 is just 1, okay? So let's move on to number 3. If you notice, the top is just one number, so I'm going to leave it like it is. However, the bottom is two different numbers, okay? So we can multiply the bases together by adding the exponents. So you must say, Mr. Gomez, didn't we just say that anything to the power of 0 is 1? Yes, you could. So you can mark that out because it goes away, because anything times 1 is the same thing, so it's really not going to change the problem. And we're going to be left with 10 to the power of 13. Or you could have done multiply the same bases and add the exponents, and 0 plus 13 is just an exponent of 13. So it wouldn't matter if you use the 0 exponent rule or if you use the multiplication rule, you're still going to end up with the same number at the bottom. Now I can do my quotient rule. When dividing the same base, subtract the exponents. So the top exponent minus the bottom exponent. So 10 to the power of 7, 8. Okay, so 10 to the power of 8. And there's your final answer. Okay, let's move on to the back. Let's do a couple schoolnet examples. So let's start with number 1. If negative 3 to the power of 5 times negative 3 to the power of 2 equals negative 3 to the power of x, what is the value of x? So in other words, they're saying, okay, if my problem was this, and I asked you to simplify, what are you going to get as the exponent after you simplify? Well, okay, we're multiplying the same base. So that means we add the exponents. So 5 plus 2 is 7. Because remember, we're using the product rule. You multiply the same exponent, if you're multiplying the same base, you add the exponents. So clearly they said, okay, so if you do that, what is the exponent you get over here at the end? Oh, we get 7. So my answer is 7. Okay, let's move on. Which of the following is equivalent to this? Okay, so basically they're asking me to solve this, okay? So I'm going to rewrite the problem just so I can have room to work it out. And if you notice, instead of just putting it down as a 10, I did 10 to the power of 1. Because anytime a variable or a letter or a number has no exponent, it's implied to be a 1, okay? So here we go. So we're going to multiply all these 10s together because that's what the product rule. If you multiply the same basis, add the exponents. So let's add all those exponents together. 1 plus 4 plus 3 plus a negative 5. So let's see. 1 plus 4 is 5 plus 5. 5 plus 3 is 8. Minus 5 is 3. So there's my final answer. 10 to the power of 3. Let me double check. 1, that will be 5 plus 3 minus 5. Yep, 3. Just making sure I added and subtracted the exponents together correctly. Okay. Moving on. Number 3, simplify that. Okay, that's pretty easy. That looks like the problems we did yesterday. If you're dividing the same base, subtract the exponent. So 9 minus 3. The top exponent minus the bottom exponent. So 9 minus 3 is just 6, so we're left with 6 to the power of 6. The answer is B. Number 4, which expression is equivalent to 6 to the power of 30? So let's go through and solve each of these answer choices and see which one gives me 6 to the power of 30. When you're multiplying the same base, you add the exponents. So negative 10 plus negative 20. So negative 10 plus negative 20 gives me negative 30. So when I simplify this answer choice, I get 6 to the power of negative 30. That's incorrect. We're looking for a positive 30, so it's not A. Let's do B. When you're multiplying the same base, you add the exponents. 5 plus 6. So 5 plus 6 is 11, so I get 6 to the power of the 11. That is incorrect. We're looking for an exponent of 30. When you multiply the same base, you add the exponents. 12 plus 18. So when you add those two numbers, you get 30. So 6 to the power of 30. That is exactly what we were looking for. So my answer is C. Some of you could have made a mistake here because you're thinking, okay, we're multiplying the same base, and then somehow you get mixed up, and you end up multiplying the 5 and the 6, and say, oh, 5 times 6 is 30, so this is my answer. No. Remember that the rule says when multiplying the same base, you add the exponents, okay? Moving on to the next problem, okay? What is the value of 5 to the power of 3 divided by 5? So let's rewrite this problem as something we might recognize. Remember that division just means fraction. So I can say 5 to the power of 3 divided by 5. And remember, if a base doesn't have an exponent, it's implied to be a 1. So I'm going to go ahead and add an exponent of 1. So here's my problem. Pretty easy. When you're dividing the same base, subtract the exponent. So 3 minus 1. The top exponent minus the bottom exponent. So 3 minus 1 will give me 2. So 5 to the power of 2. Now, you might say, well, Mr. Gomez, I don't see that answer right now. And that is because they went ahead and simplified 5 to the power of 2. So we know that 5 to the power of 2 basically means 5 times 5 because we've already talked about this. And 5 times 5 is 25. So really my final answer is C, 25.